Hello Dev, welcome to the channel. Today we'll talk about the facade design pattern. What is the facade design pattern? How is it implemented? Let's take a look. Let's say you're working with a complex third-party library which you need to interact with multiple services to accomplish the desired result. The facade design pattern will help us reduce the dependencies by placing those service interactions within a front-facing class known as facade. What is facade design pattern? It is a structural design pattern that provides a simplified or unified interface to a library, a framework, or a set of complex libraries. It provides a simplified interface to interact with those libraries or frameworks. When I say interface, I'm referring to the way you interact with the library, and not necessarily interface in the Java terms. It might provide limited functionality to a library, but it only comprehends the important aspects for a client. What are the elements of the facade design pattern? First, we have the facade, which is typically a concrete class providing access to a specific part of the subsystem. This is the one that acts as an interface to the system. If our facade is becoming too complex, we might break it into multiple facades. And finally, we have the client, which is the piece of code that actually uses the facades. Let's take a look at the diagram. So here we can see the class diagram that represents the facade design pattern. Here on the left, we have the client, which is the piece of code that is going to interact with the facades. Here at the center, we have the facade, where we can have objects representing references to the subsystem classes or the libraries. It provides methods or interface methods that enable us to interact with the libraries. And again, if it gets too complex, we might break it into different additional facades to interact with different parts of those libraries. Let's take a look at the code. Let's explore the facade project. Here we have the facade project. We expand the project. You can see that we have buy crypto facade and run facade. First, I'll go to run facade. In our main method, very simplified, you see that we have a reference to buy crypto facade. We instantiate that facade, and then we interact with it through this method buy cryptocurrency amount of 1,000. So we'll interact with a third-party library that enables us to buy cryptocurrencies. It is probably a very complex library, but you see that we just invoke one method to interact with it. That's why we're using the facade. If we take a look at the facade, it is going to be the front-facing part of our code that enable us to interact with the complex third-party libraries to buy cryptocurrencies. It is not an actual third-party library, it's just going to be the representation of it. So before we dive into the buy crypto facade, let's see the third-party library. So here we have all the classes that make up the third-party library. If we had to interact with all those parts of the code individually to buy cryptocurrency, we would have a tightly coupled system where our client, in our case our main method, we were going to invoke all of the different pieces of the library in that method. It could be different methods for sure. In this scenario, we're referring to our main method. So to buy cryptocurrency, you have all of those service classes here. We're putting everything into the facade. So the facade becomes the responsible for dealing with all of those complex interactions. So let's take a look at the buy cryptocurrency method. It only takes an amount and the currency. So what are the steps we have to perform to actually buy cryptocurrency? First, we interact with the database service, which retrieves a user with db service get user. And from the UI service, you get the current logged in user. So we interact with two services already, the DB service and the UI service. Then we check if the user that we retrieved, if their balance is actually less than the amount you're trying to buy. If it is greater than that, insufficient balance, you cannot buy it. Otherwise, our code keeps running. We interact with another service. So from our crypto factory, we try to retrieve the crypto service of that specific currency, which we passed as an argument here. And then we invoke the buy currency method, passing the user and the amount. Then we get the mail service to send a confirmation to the user that their purchase was successful. And finally, we're printing the successful message. I didn't have to go into the details of each service here, because we just need to demonstrate that the facade hides all of that complexity. So whoever uses the code, or the client, in our case, run facade class that has the main method, just has to deal with one method call. If the interaction with the library changes, you have to change the facade and not the actual client code. So if I run this, you'll see that we are buying $1,000 or 1,000 of something of Bitcoin. We're sending an email to John and we say the message 1,000 BTC bought successfully. The client code doesn't know all the complexities required to buy the cryptocurrency. We interact with the library through the facade. And what are the key points of the facade design pattern? It hides the complexities of a subsystem by providing a simplified interface to interact with those classes. Remember, when I say interface, we're talking about the front-facing part of the code to interact and not necessarily interface in Java. It loses coupling between clients and libraries by providing a higher level of abstraction. The downside is that sometimes it can become a bit too complex, so you might consider breaking your code into separate facades. And that was Facade Design Pattern. I hope you enjoyed this video. Hit the like button, subscribe to the channel, and I'll see you in the next one.